All right, in this exercise, I'm going to work with this discrete probability distribution I have on the left, and we're going to calculate the parameters, specifically the mean and the standard deviation of this distribution. So, couple of things. First, the mean of a probability distribution is equal to its expected value. And before I do any of these calculations, let's just verify that this is indeed a probability distribution. So for this to be an actual probability distribution, the sum of the probabilities must be equal to exactly 1. So this is accounting for all possible outcomes of an experiment and the corresponding probabilities. So let's just sum these up just to verify. And yeah, so the sum of the probabilities is exactly 100%. So this is indeed a probability distribution. So now let's calculate the expected value first. So for the expected value, we need what we have over here, the sum of x times p of x. So we'll need, for each x value, we'll need to calculate x times p of x. Say equal, let's just do x times p of x. So down here, we'll say this is equal to a2, which is our x value, times b2, which is our probability. And we'll copy this down. Oh, let's turn that off. Okay, so let's copy this formula down. So here are our, let's get rid of this red dot here. Equal our x times p of x. Okay. Okay, so it looks like that red dot's going to be there. We'll have to just ignore that. And so let's go down here. For the expected value, we're going to add up all of these individual values, x times p of x, and we'll sum these guys up. C2 through C11, and the mean of the distribution, or the expected value, is 4.4. Now, for the standard deviation, we're going to need x minus the mean, and each one of these x minus the mean values, we need this squared. So let's do x minus the mean and square it here. Okay, so let's do equals, in parentheses, just like the formula says, equals x minus the mean, close parentheses, and we'll square that. Okay, so now before I hit enter, before I copy this formula down, for each x value, I want to reference cell C12. So first x value minus the mean squared, and then second x value minus the mean squared. So in every case, I want to use the 440. So when I copy this formula down, Excel is going to update the index. So the A2 will become A3, and then A4, and then A5. And the C12, when I copy it down, will become C13, and then C14, and C15. I don't want the C value to change. So we're going to use, and we've seen this before, we're going to use a $sign to freeze the index on the C12. So now with the $sign there, when I copy this down, the next formula in the next cell is going to say A3 minus C12, quantity squared, and then A4 minus C12, quantity squared. So remember, the $sign freezes the index when we're doing repetitive calculations or when we're copying a formula down in Excel. Okay, so if each one of these values is x minus the mean quantity squared, and now we want to multiply that by the probability. So you could, we could have done it all in column D, or we could do it in 2 steps. So we'll do x minus the mean, close parentheses, square that, and then let's throw some more parentheses in there. And multiply this by probability. And I'll open that up. Okay, so I'm taking D2, that's x minus the mean squared, and multiplying that by the corresponding probability. Okay, and I'll copy this down. Excel will do all the repetitions of the formula. And down here, the next yellow cell, I want the sum of all of these values. That's what's going on here in the formula. And then I want the square root of that. So let's do equal, and again, you could do this in 2 steps. You could do the sum first and then take the square root, or you could do it all in 1 step. I'm going to do it in 1 step. So equals square root of the sum of this column. Okay, so inside, this is the summation of all of the x minus the means times the probability, and then on the outside I'm taking the square root of that value. Okay, so, and we could decrease the, decrease the number of decimal places here if you like. So approximately 5.086 would be our standard deviation. Okay, and that about does it for this one.